provision the large like servers, and where so I mean, the virtualization stuff is like lot of those things are being uh, have reduced. And like then the second point, what we see that so the
What is the problem with virtualization? Why the virtualization should be reduced?
I mean the infrastructure, what we were doing, the operating system,
Mhm.
resource usage is also is costly, right? So the Docker or the containerization helps us to more we use the resources more efficiently,
Mhm.
is one thing. And suppose your the containerize also helps us to like ship or the software easily,
Mhm.
and run it in a homogeneous environments where less chances of errors.
Mhm. Okay.
And yeah.
Okay. That is good enough. So just want to know what do you mean by resource usage? So let's say if I'm running an application on virtual machine and I'm running a virtual, see, let's assume that we are running, what can I say? Let's say, yeah, you're a database guy, right? So let's assume that we are running MongoDB directly on a virtual machine, and we are running MongoDB directly on container in the same virtual machine. How both are different?
Mm, yeah, so good question. So but
So,
difference would
mm,
be uh,
and one more add on. So can you run a container without an operating system?
no.
So that means, I mean, you said something about virtualization. So I'm just trying to connect back
Yeah.
the dots. Yeah. So yeah, you tell me that MongoDB thing, the question one. Yeah.
Yeah, so
It's fine. You can say whatever that comes to your mind.
yeah, just thinking about
Okay. Formulating
yeah,
those
right,
things.
yeah.
Yeah.
That
Yeah.
means like so suppose we have a lot of high traffic, right? So
Mm,
uh, the scale up, scale down, those things are always like we don't know what when that happens, right? So when we are using a MongoDB on over
mm,
yeah, I mean that also can be done.
yeah.
I'm not sure. I mean, I'm not getting the.
Very good.
So yeah,
No problem, Shri. No problem, Shrikant. Sorry. I'm just calling Shri because I have my friend whose name is Shrikant and I call him Shri. Okay, so I'm
no
really sorry.
problem, no problem. Yeah.
Yeah. So Shrikant, the thing. So it's very important, because many people think that learning is, it's okay. This trainer is great. This trainer is bad, or something is good. So ultimately, what matters is the question. It's not the educator or it's not the concept that automatic or there's some theory that will always teach us things. It's the question, the question that we have, and what is the solution to that question generally helps us to finding the answers ourselves, right? So yeah, so I think as a platform engineer it is very important to understand the nativity of the containers, right? Because if you ask any of the people nowadays who work in containers to an extent, most people say, yeah, it's portable, you will not have version dependencies, it's a package where you can run on any operating systems, and you don't your application will not be stuck because of the packages or the version inconsistencies, because you package them together in the form of a container and you supply them. So I think and this can be used in pipelines and stuff, and it really makes the job easier. It's very fast, portable. These are the things which generally people speak. They are 100% right. There's no doubt about it. But as a platform engineer, we cannot just ride on telling the advantages. Okay, we should try to explain to the people what is the concept in containers that is actually leading to these advantages. So advantage is something which you get after deciding uh, to onboard the tool. Okay, so let's say Shrikant is very honest, is very humble. That's an advantage, but that advantage cannot be a decision making to onboard you. It's the skill that is needed. Okay, so the skill of containers, let's try to understand. So going back in a era of traditional computing, so I think we used to have bare metal servers. Okay, so I am assuming you are aware of this word, right? You would
Yeah,
have
yeah,
heard this
yeah.
word ever, yeah. So where there used to be bare metal servers, where there is one large hardware, and you install operating system on top of it, and you can. That's the way of how you can use the hardware, right? So let's say there is 8 CPUs and 8 CPU and 64 GB memory, okay, a RAM. So when you install operating system on top of it, all of the bare metal hardware can be used by this operating system. And on top of this operating system, you will install the application. Okay. So
Mhm.
this is very good enough. But this was only the way that was available in traditional computing. This is how it used to happen. But then people used to ask, okay, what if the operating system is down? What if you want to update your operating systems? What if there is some maintenance activity that is going on? How much downtime is being expected? So definitely, if there is only one operating system, till the operating system is up, you will definitely have a downtime. Downtime used to happen for 2 days, 3 days, or 1 week also sometimes whenever some maintenance is happening. Or let's say there is some disaster that has come near the wherever that bare metal server is placed. Okay. They used to have so much of inconsistencies in maintaining the what do I say, supporting the internet revolution actually. Okay. So internet is a very great tool that really help people connect with one another. But the platforms that run on top of it used to run on bare metals, and they used to be very highly inconsistent. Okay, so that is when people thought. So the problem is not the hardware, because see, if just for the availability, all you want is another instance of the application running in a different IP address. Okay, the challenge is not the hardware. The challenge is the operating system. Okay, your application is consuming, let's say it's consuming 10% of what is available, but still, in order to be available, you know you cannot have another operating system. You need to restart or update the operating system. Your application is going to be down. So the challenge is not the hardware, the challenge is the operating system here. Okay, so that's what led to something called as, okay, so bare metal, where we have this 8 CPU, 64 GB RAM. Okay, so that is where we have this framework called as hypervisor. Okay, so this one software component that's put to BIOS, so where it will work with your hardware. And this software component, what it will do in front of hardware is, this is responsible for splitting the resources and creating and assigning it to operating systems, right? All hypervisor does is it splits these resources. Okay, so even though if you remember the XP and those kind of era, when you start the system, you remember Windows XP and all, right?
Yeah, yeah.
Yeah, so we used to have that BIOS things where we can set some memory, CPU, and create certain operating systems as well, back in those days. So anyhow, so coming back to hypervisor, so this is a component that splits the hardware and extends it to different operating systems. So using hypervisor, you can have operating system one, where you can give it to CPU, 4 GB memory, and you can run your application on top of it. And similarly, you can have an operating system 2 with another split of memory and CPU. Okay, just a sec. Yeah, operating system 2, where you have 2 CPU and, or let's assume 1 CPU and 2 GB memory. Okay, and you can run another instance of an application here. All right. So like that, the rest of the hardware can be used in order for future correspondence where you can create another operating systems and run the application. So this gave the isolation. So you're abstracting the operating system. Sorry, you're abstracting the hardware here. Okay, you're abstracting the hardware and you can create multiple operating systems and you can run applications on top of them. Okay, so this led to the world of virtualization. Okay, this is what you meant by virtualization, right? So
Yeah.
without hypervisor, there is no cloud computing only in the first place,
Yeah.
right? Because cloud computing works on this concept of virtualization. If there is no virtualization powered by hypervisor, there's no cloud computing today. Okay, so when you said that, okay, we can use less of virtualization, so I was just stressing on that word because virtualization is the one that is powering the entire world right now. Okay, but yeah, so there are definitely challenges. We'll come to that. But here, if you see, this is a very solid use case for an enterprise ecosystem. Hypervisor plays a very important role. And by the way, even today, it plays a very important role. Maybe the demand has come down, but it definitely plays a very important role. All right. So I think this virtualization era used to be a great tool till monolithic applications. So as far as monolithic applications are concerned, this is the only way. Till today, even if you have a monolithic application, no one will ask you to containerize. If anyone is asking to containerize monolithic applications, then trust me, you have to come out of it at this as much quickly as possible out of it, because containers are not actually meant for monolithic applications. Okay, so monolithic application, you understand what's a monolithic application,
Yes.
right?
Yes.
Where you have only one package,
Yes.
so whether you have front end, back end database, or any of the middleware components, everything will be packaged as one unit. You have one WAR file, one jar file, or
Hmm.
one Python package or npm package. You deploy that in your production server, right? So it's all or zero. I mean, it's either binary, it's one or zero. Either you take everything back or you put everything up. Even if you want to make a small change, you have to take the package down, update the entire thing, and again repackage it and send it, right? So that there's only one command. There used to be only one command, one server, and you run it. Okay, so how do you make your monolithic application available? You run one package here, one package in the other application. That makes it available. So I think for monolithic application, virtualization is the best, because virtualization came only in the monolithic application era, and it survived till 2015, 2016, right? So
Yeah.
that is when as your code base increases, add your integrations and applications increases, there came an era of microservices. Okay, microservices, where there are independent packages for front end, back end, and DB. Okay, so
Yeah.
now we used to say, now okay, now you might have a front end, but front end is not one package. In front end also there will be multiple packages. We used to call micro front ends. Okay,
Hmm.
component based packages we used to have. Then we used to have backend. In backend, for every API, you will have a different deployment. You have a different package. Database also, integrations of database also can be different packages.
Yeah.
Now the
Different.
problem, yeah. Now the problem is, where is monolithic? Where is one package? And for the same application, let's say you have a small full stack application, you might have to do at least 10 deployments. Even if you take 3 instances of front end, 3 instances of backend, 2 instances of DB, eight deployments you need to do. So 8 times you need to have 8 servers and you need to do 8 deployments,
Yeah.
right? So very challenging. No, why I say 8 servers? You can say, Miss I, why Surya, why 8 servers? Why all these things, different packages we can run on one operating system also. You can run. No one is stopping you from running it. But how do you assign the resources? Why I have asked you regarding what is the difference of running Mongo locally and running Mongo in the container. You can try it out once. You execute Mongo. I mean, definitely you would have tried out. Only thing is you would have not have noticed from that perspective. Just because you asked me to give a demo, I'm giving a demo. I've asked you that question, but that's not a general question which everyone will see.
Yeah.
So yeah,
We have VM.
yeah.
Okay, where we are running MySQL as a container in
Hmm.
production.
Hmm.
Okay, so there was my question also when I joined here. I mean, why not simply just install the MySQL directly on the OS? They said, okay,
Absolutely.
we were actually planning to move it to more like, because all of the everything is running on the containerized environment, so better. I think we are also moving MySQL to that. So
So see, that's what I'm saying. So maybe the person who would have set up that project in that way could be an architect, could be a platform engineer. The one who is following it up, they might be in their own experience, their own knowledge of, okay, just continue what's already there, why to disturb. Okay. So I think it's great that you also had that question. I think the thinking is right, the questioning is absolutely right. Uh, Absolutely want to appreciate you for asking that question at that time. So I'll tell you, Shrikant, what's the problem? So if you run MongoDB, so forget about the project. You today, after this session, you install MongoDB in your system. Okay. So just try to perform some interactions, CRUD operations, aggregation queries you perform. And you open your task manager and you check your resource utilization. Okay. It will not be less than 95%. Okay. So the point is, MongoDB or any of the database, see, it works on storage and memory. Okay.
yeah,
Because, because see, let's assume that you have 10 eggs in a basket. Okay. So if I am sitting like at 100 meters distance, I'll ask you, Shrikant, can you just pass it on? Okay, maybe eggs is yeah, let it go for now. So uh, will you bring two eggs with two hands, or will you bring one egg each time? You obviously tend to bring two eggs each time and do the 5 rounds, right? I hope that's how we do it.
yeah,
Right? Yeah. So, but can you not do with one egg per 10 rounds? You can also do that.
yeah,
But why are you not doing one egg 10 times? Why are you doing two eggs with two
Eff-
different hands? Because you have two different hands.
yeah. The efficiency to being more efficient, right? So
Yeah, yeah. So now my point is, now MongoDB, when any database it is there, when it has to go and process your query from its storage. Okay. So when you run a query like an indexing query which has around 10,000 records, now your memory, let's say here you have the memory of 64 GB. Okay. So why it has to use only 10 GB? It will use entire memory that is available in your virtual machine to
yeah,
get the query as fast as possible, as quick as possible.
yeah,
But that will affect other applications running in your machine.
yeah,
It will stop other applications running in the machine. It will exhaust the memory for other services that are running in your machine.
yeah,
That is why databases are specifically run as containers, because when they run as container, when you create a container, you will create the limit of saying that, boss, this container can only be given 10 GB of RAM and one CPU only. So if you execute a query, that database will only use the memory that is allocated to it and get you the response. The response might take another 1-2 seconds of latency, but it strictly does not use beyond that.
yeah, yeah,
Okay.
yeah,
So that is the advantage of running the service as a container compared to running services inside the virtual machine directly, because in virtual machine you can never restrict it, but in container you can restrict it. So that is why when you talk about resource utilization, that is the power. Okay. So container also runs on operating system only. Okay. So on top of your operating system, to manage the containers, you install something called as Docker. Okay. So Docker engine. So Docker engine, how will it work? It will use the kernel. So it will abstract the kernel from operating system, because kernel is the one that is responsible for assigning the resources like CPU, memory to all the tasks that are running on your system.
okay,
Excuse me. So Docker engine works well. It abstracts the kernel, right? And using Docker engine, you can control the kernel. So using Docker engine, you can say, boss, this app one which is running can use 0.5 CPU. Excuse me, 2 GB RAM. Then app 2, you can say 1 CPU, 2 GB RAM. Okay, like that. So like that, the available hardware or in the operating system, using your Docker, which internally abstracts the kernel, it is able to split the hardware into different applications, so that these applications if cannot use beyond the memory and CPU allocated to them. If it uses, it simply restarts. The container restarts if it is using beyond what is allocated to it. Okay, so that is how your Docker works on top of your operating system and helps you make sure that your applications are having a better resource utilization. Okay, so then what happens? So this particular era, this particular Docker, this particular container era using the software called as Docker will be able to support multiple microservices in one operating system itself. Because what is the problem in running multiple services in one application? Resource utilization. Because backend can use more. If backend uses more, frontend won't work. If frontend use more, database won't work. So how will you segregate them? Using these containers. Okay. So as a platform engineer, what is the problem that it is solving for the platform engineer? This is the problem it is solving for the platform engineer. Okay. Make sense?
Yeah.
Any doubts?
Just I was thinking about like you said, um, if you're running a process or any service inside a OS without Docker, without containerization,
Hmm.
yeah, we cannot have any limit on the resource how much it will be used, right?
Hmm. Hmm.
Right. So I was thinking like Java has some values like say XMS values and all where we can set, but yeah, it will cache lot of other resources also. So yeah, that's what I was thinking.
Yeah. So
Yeah.
you're installing Java software. So inside that, maybe there is something, but I'm in general talking about applications on a whole. It's
Yeah,
not
yeah,
all the
yeah.
application supports that. Yeah. Java has indexing and memory. Some internal packages through which it might be doing, but it's not applicable to all the applications around.
Yeah, even for MySQL also. So if we are running as a container, we can specify the limit of how much
Yeah,
memory.
in the container, not in the
Yeah.
virtual machine.
In
Yeah.
the virtual machine, we cannot do that. We it
Yes.
will
Yes.
have been experience all that. I mean,
Yeah.
traffic events go high, then
Yeah.
VM go. We cannot do SSH to that VMs. Yeah.
Yes. Absolutely. Absolutely. You cannot do SSH. But imagine other applications that are running on the virtual machine.
Yeah.
So if you are saying that no, Surya, that can be solved by running different microservices across multiple virtual machines, then you will be having 15 virtual machines. Your cost will be 10x,
Hmm.
right? So that is why container is the solution for microservices. Okay. So I hope why containers are existing. It's a bit clear for you now.
Yeah.
All right.
Basically,
So
the efficient usage of
yeah,
resources available. Yeah.
absolutely. So I think let's just a sec. Yeah. So let's talk about certain terminologies that we need to understand before. Generally we get on board with containers, Shrikant. So the first thing is something called as Docker engine. Okay, you're aware of what is this Docker?
Yes.
Hmm.
So yeah. So Docker engine, which controls all the containers, right?
Yeah.
Creates like operation all those things.
Yes. Yes. So it is the software that manages it's not a software actually, it's a runtime. Yeah, it's a runtime that manages the life cycle of containers.
Okay.
Okay, so life cycle of containers is nothing like create, modify, run, delete, everything related to creating, running, building the containers. It is done using this Docker runtime. Okay, so every operating system should have this runtime, then only you can execute or create the containers. Without this Docker runtime, you will not be able to uh, run or execute the containers. Okay, so there are so many other runtimes like this. So Docker one is one option. You have
Yeah.
Containerization also, which Kubernetes uses.
Podman.
Yeah, Podman is also there. So there's so many runtimes, but Docker is the most popular one. Okay. All right. So that is about Docker engine, and now we need to speak something about image. So you have any information on what's an image is all about?
Yeah, so this is the package of
Yeah,
the software. What?
exactly.
Yeah.
So image is nothing but package containing your software, your dependencies, uh, code, and your environment configurations. I mean, startup scripts and all those things, right?
Hmm. Hmm.
Because it is not just important to share the code with others, but it's also important to share how to execute this code. If you go to the Git and all, there will be README files. But when
Yes.
you're passing the container, your container should internally already have the things automated on how to execute the application inside the container. Okay,
Yes.
so that is all about your environment configurations. So that is part of the image. So you share images, you build the images. Okay, so generally people use image and container equivocally. Okay, but that is not correct. Okay,
Yeah.
so image is actually the package, and container is nothing but a running process of the image.
Yes.
It's a running process of the image. So that is what a container is all about. So people say container, I mean, people generally assume container itself being a package of software and all, but ideally that's not true. It's the image, and container is just the running process of the image. Do you know what Docker file is all about?
Uh, Docker file, I can say, is like a blueprint how the container will run,
Hmm.
right?
Yeah.
I
Not
mean,
how,
we
yeah, not how the container is run, but how the container is built.
okay, yeah, yeah, container is
Yeah.
built, yeah,
So it is set of instructions that contains layers. Okay,
yes,
in how to build the container. Okay, because here we spoke image is nothing but, sorry, how to build the image. Sorry, again, we should not use the word container. Yeah, so we are saying image is nothing but package containing software dependencies, code, and environment. So how will you package them, right? So it's not like you package whatever you want, right? There is a certain way in packaging, which software you will bring, what is the dependencies that you will add, what is the code that you will add. It's very important to have the proper wiring of the things. So
mm,
Docker file will have that information on how the image is being built. Okay.
yeah,
Yeah. So then you have Docker Hub. You're aware what's a Docker Hub?
yes, yes.
Yeah, it's a
Docker
registry.
Hub, yeah, registry,
Registry uh, to
state,
harden or store the
image,
image. Yeah. Okay. So many registries are there. GitLab also has a registry. Docker Hub is there. You have AWS, GCP. They have their own artifact registries. I think, in fact, your Ask also is one of in GCP is about artifact registry, if I'm not wrong.
mm,
So yeah. So it's just an alternative to Docker Hub. You can store your registries in artifact registry as well. Okay.
yeah,
So these are some of the terminologies of Docker. So I'm sure that's fine. But yeah, we will go to the demo of Docker, once you get on board. But just want to know also your understanding on, if Docker is there to maintain containers, why do we need Kubernetes? Why do you think that we need Kubernetes?
Kubernetes give us this uh, I mean lots of, I mean, tools or this thing like help us, like maintain this, keep these containers running.
Hmm.
That means suppose we want to run a container, if whatever stops it, how it won't restart on its own, right? So if you have a deployment in the Kubernetes, it will automatically reconcile, okay, see, this is the one pod is, I mean, terminated, that will automatically start those things and other dependencies also. So it's kind of a managing the containers, I can say.
Yeah. So managing containers is not the right word, Shrikant. So managing containers, Kubernetes also takes the help of a runtime only. So Kubernetes also used to use Docker runtime till 2020, 2021. I think in the last couple of years back, they shifted to container team. Okay. So Kubernetes is not capable of maintaining containers on its own. It uses containerd. Before that, it uses Docker as well. So Docker, Kubernetes, containerd, they are complementary in nature. Okay, but yeah. So if you observe very clearly, Shrikant here, where is Docker engine? Okay, how do you how does how do you manage containers using Docker engine, right? So
Yeah.
where is this Docker engine inside this operating system?
Yes.
Okay, so that shows one disadvantage of Docker. What is it? The disadvantage of Docker is it can only maintain and manage the resources that can be deployed in that particular operating. I mean, the containers that are running on that particular system itself.
Okay.
Okay, so see, but often microservices are split into multiple machines, right? So you can have front end one running here, front end two running in a separate machine. How
Yeah.
can Docker manage both? It cannot. Why? Because Docker has a dependency on the operating system. You install this engine separately on the operating system. How can it? How does it know the status of the replica instance that is running in a different virtual machine?
Oh, got it. Okay. Understood.
Right? So
Yeah.
that is a technical challenge. So it's a technical challenge. It makes sense. I mean, you are right now in this call. Right now, how will you know what's happening in your project call? Or let's say there is some stand-up call happening in your office. How will you know that information there? You will not know. Because
Hmm.
right now you're streaming to me. You're viewing what my session, right? So that is a technical challenge with the Docker engine because it is installed on top of the operating system. So it will not know what the process happening at hypervisor level. So it will only know the containers that will running on this particular operating system only. Okay, so that is where Kubernetes came into the picture. So Kubernetes says, boss, I will help you in orchestration of containers across uh, nodes. Nodes is nothing but virtual machines. Okay, they call it as nodes. So Kubernetes has this entire cluster ecosystem. We'll get into that more, but the nature of why Kubernetes existing is one container you will be able to manage across multiple operating systems using Kubernetes. So Kubernetes can deploy multiple containers across multiple instances, manage their scalability, manage their health checks, auto healing, auto scaling, everything it will be able to, right? So that is why at an enterprise level, if you want to manage containers, Kubernetes is the only way that is available to the companies at this point of time. Yeah, I mean, there are some stateless workloads have come, like, AWS has ECS, GCP has Cloud Run, but they're only for running some stateless applications. Yes, you can say some business of Kubernetes have taken over by them, but when it comes to complicated and stateful applications, Kubernetes is still ruling, it's still the boss. Okay.
Yeah.
Yeah, makes sense.
Yes. Uh,
Or
what is distroless?
what is it, Shrikant?
Distroless image.
Distroless image. No, I have not heard about it actually.
Okay.
From where you have
So so the applications, the Go packages and all. So we use distroless
okay,
images.
okay. So I believe. See, I think when you run with, I think maybe they might not have the. What I mean is, there are some kind of see, whenever you go with certain base images, right?
Mm-hmm.
You like Ubuntu, Linux, and stuff. Whenever you're going with such base images, you automatically will have the shell commands and all that stuff. Okay,
Yeah. Yeah.
system utilities will be installed. Maybe in whatever distroless images you are saying, I think the package managers, the shell utilities, those things will not be there. The major benefit would be to keep it lightweight. Okay,
Okay.
so I don't know if that is what it means. Okay, yeah, see, that's what. Okay, so they are
Mhm.
the way to keep it lightweight. Okay, I don't know this term, but I what we have is we always have a process of hardening of these images to make sure that we remove all the utilities and components that our container might not be using to reduce the system size of that image. Okay, so
Okay.
we have certain softwares that we internally use to make sure that, so whenever your base image is used, your base image will automatically will have some packages which your code might not be using. So it will increase the time taken, startup time, it will increase, right, for you to scale. When you scale the application, the startup size makes sense. Startup time really adds up to the latency.
Okay.
So the best way is to remove certain things which might not be needed to you, So
Any open source tool you're using or just your internal?
no, we have our own internal tool, Velocity AI, for that. So we do that actually.
Okay.
Okay, because open source tools for such kind of things are actually not reliable.
Yeah, nowadays.
Yeah. Okay, they call Docker on a diet. Great.